Hey, welcome to Tricksaw. Today we'll be discussing the chain rule. In calculus, when you have to find the derivatives of more complex functions, you have to use the chain rule. For more simple functions, you can use something called the power rule, which should be reviewed by now. What the power rule states is that the derivative d dx of a function x to the a power is equal to a times x to the power of a minus 1. And so this rule is more useful for simple functions in which it's just a function x to a power. Examples of this could be x cubed or just the square root of x. Any functions that look like this or are similar, you can use the power rule pretty simply. But for more complex functions, namely composition functions, the chain rule becomes a necessity. So what is a composition function? Let's start off with that. So a composition function is any function that follows the form f of g of x. So this may look a bit weird at first. It's a function inside another function, but that's what it's supposed to be. It's a function composed of another function, hence composition function. So the chain rule is about finding the derivatives of composition functions. But where can you see a composition function? Well, it's really everywhere. You just need to find how to break a function down in order to make it as one. Let's start with h of x is equal to sine of x squared. Even though you may not realize it, this is a composition function. Let's start with f of x. F of x is the outside function. So what's wrapping the inside function? Well, in this case, f of x would be sine of x, because sine is on the outside of our composition function, h of x. And you can see g of x is on the inside. So what is on the inside of sine of x squared? Well, g of x would be x squared. So, as I said, the most basic skill in using the chain rule, you need to know how to break down a composition function and analyze it for its parts, the inside and the outside. And that all leads towards finding the derivative. So how can you find the derivative of a composition function? Well, according to the chain rule, the derivative d dx of f of g of x is equal to g prime x times f prime evaluated at g of x. So let's break down what this is saying. If we have a composition function, the derivative of that function is equal to the derivative of the inside function times the derivative of the outside function evaluated at the inside function. And the best way to understand these concepts and processes into deriving a function, the best way to do it is practice problems. So let's do exactly that. So let's start off with, let's say our function h of x is equal to, let's go with sine of x squared. I like that example. We're trying to find h prime of x, or the derivative of sine of x squared. Well, let's first analyze this as a composition function of the form, let's say h of x is equal to f of g of x. So what would f of x be? Well, we've already done this example. F of x is equal to sine of x, and g of x is equal to x squared. And what else do we know? Well, we know that the derivative of f of g of x is equal to g prime of x times f prime of x at g of x. So now it's pretty simple. All we need to do is we need to plug in. So let's start doing that. So h prime of x is equal to g prime of x, which is, if g prime is x squared, what is the derivative of x squared? Well, according to the power rule, it's 2x. So h prime of x equals 2x times f prime. So what is f prime? Well, if f of x is sine of x, one of our trigonometric derivation properties says that the derivative of sine x is equal to cosine x. So it would be 2x times cosine x, still evaluated at g of x, which is x squared. So it would be 2x times cosine of x squared. So our final answer would be the derivative of sine of x squared is equal to 2x times the cosine of x squared. And that's how you can use the chain rule. You know, this is a very specific problem, like using a trigonometric function with a power rule inside. But there's so many combinations you can use the chain rule for. And there's so many uses for it, and that's why it's very important to know. But to review, the most important step is knowing how to break down any composition function, which is, as I said, a function with another function inside of it, or composed of an inner function. And then all you need to do is you need to memorize, or understand if you can, the formula, which is the derivative of a composition function is equal to g prime of x, or the derivative of the inner function, times the derivative of the outer function evaluated at the inner function. Thank you all for watching this video. I appreciate all the support. If you have any questions or comments or any video requests on any topic, physics or calculus you'd like me to discuss, just leave a comment down below. Make sure to subscribe, and as always, thank you for watching.